On 32, we'll start by listing the transformations, and then we can figure out the period and the range after that. So if we label again, A and B go on the inside from left to right, C and D go on the outside from left to right, and we see an A transformation there, which means I'm going to have to factor that 1/2 out. So it's going to look like this when I factor the 1/2 out. If you factor a half out of 3, how many 1/2s go into 3? The answer is 6. So if you, or you could check by distributing back. 1/2 times -6 would give you the -3 pi that's in there. So my A transformation is this 1/2 right here. So that is a horizontal stretch of 2. And then my B transformation is a shift right by pi over 6. My C transformation is a vertical stretch of 2. And then my D transformation is up 5. So it's helpful to know kind of in general what the graph of tangent looks like. And so if we were to graph the tangent of x, it goes like this. It kind of has this S-like nature. It kind of looks like a cubic graph, and it just keeps repeating that. Remember, it is cyclical just like sine and cosine are, but it is not a wave. It's we have all these kind of individual pieces of this graph, and they are separated by vertical asymptotes. And each of these vertical asymptotes is on pi over 2. And we know that because if we were to look at the unit circle, remember that tangent is the y-coordinate over the x-coordinate. And so if you look right here at 0, the tangent would be 0 over 1, which is defined. It's defined as 0. So at 0, my graph is on 0. But as I come around the circle here, when I get up to here, when I try to do 1 divided by 0, this is undefined. So when I'm at pi over 2 on my graph, I'm going to have an asymptote here. And then this 0 is going to happen when I'm over here at pi. And then this number is going to be 3 pi over 2. So at every sort of odd number of pi over 2's I have, I'm going to have this vertical asymptote. And I say that that's helpful to look at just so we can determine the period after I've done this transformation. So the normal period of a tangent graph, the time it takes for one cycle to complete, is from pi over 2 to 3 pi over 2. So that's just 2 pi over 2. The time that it took to do that was 2 pi over 2. So the normal period of the parent function is just pi, but if I did a horizontal stretch of 2, if I stretched it out wide twice that much, the new period is going to now be 2 pi. So keep in mind, the parent function period of sine and cosine is 2 pi to begin with, and so if I had this same horizontal stretch of a sine or cosine function, my new period would be 4 pi, but the parent function period of tangent is just pi by itself, and so after the horizontal stretch, it's now 2 pi. As you can see from the range here, even if we stretch or compress this or whatever, and we might move it left and right, like we're going to move it right 6 pi and we're going to move it up by 5, but these tails of the tangent graph they're going to continue to go down to negative infinity and up to positive infinity, and so the range of this graph is simply all reals. The domain is kind of complicated because it's like all reals except for every odd multiple of pi over 2, and we didn't ask you for that on this problem. We just wanted you to see that the range, no matter what the transformations are, the range is still going to be all reals.